Good afternoon. So, is it audible? Is it audible?
Yes, sir.
Yes, sir.
Okay. Now we'll see the next concept. Okay. So, previous we studied that is a predicate we seen, and the statement function variable we seen, and predicates also we seen the previous concept. Now, here the next concept that is a quantifier that is very important and easy also. See, quantifier. So here quantifier. See what is the quantifier? The main thing. First, before definition of quantifier, first we see the example. Then we can understand the concept of quantifier. Okay, so here there are four examples here. All. So here, wait a second. So consider the following statements. Here, so these are the primary statements. Okay, so all squares are rectangles. Okay, so all squares are rectangles. Okay, so this is one statement. Next, for every integer x, then x square is a non-negative integer. Okay, so wait a second. Okay, so for every integer x and then x square is a non-negative integer. Next example, that is some determinants are equal to, someone raises the hand, some determinants are equal to 0. Some determinants are equal to 0. This is one more statement. Next statement, that is there exists a real number whose square is equal to itself. Okay, so these are the statements. Wait a second, still students are joining here. So these are the four statement. See, some words are there, all. Okay, and here for every. Okay. So next, here some, this is one more word. Next, here we use the there exist word. So these words are telling about quantities. Okay, so telling about quantity. All means, so all the squares. So this all word, all phrase, it will telling that all the squares are rectangles. So these words, whatever here for every integer. So this every integer is a, then every integer x, then x square is a non-negative integers. Next here some determinants, that some determinants are equal to 0, and next there exists. So here these words all for every some there exist. So these words are telling about the quantity of particular things. Okay, they are telling about quantity. So what quantity here? All squares are rectangles. So then for every, so for every integer x is a non-negative integer. So that is telling. Okay, so next here there exists some real number whose square is equal to itself. So here also that is telling about quantity, particular quantity of something. Okay, so here the word all, the word all, every, some, there exist. So these all are, whatever these words are telling about quantity of anything. Okay, quantity of any particular idea. So suppose here square is this word all is telling about squares. Here for every is telling about integers. So some is here, some is telling about determinants. There exists, this word, this phrase is telling about real numbers. So whatever these words or phrases are telling about some idea or something is telling about quantity. Okay, so these words are called quantifiers. Okay, so these words are called quantifier. All, every, some, there exists at least one. So these words are telling about some quantity of any ideas. Okay, so any quantity about anything. Okay, so that these words are called quantifier. Very important, these words are called quantifier. Any doubt about quantifier? It will telling about quantities of particular things, particular ideas. Okay, so that is quantifier. Any doubt? Any doubt? Understand or not? Quantifier, very important concept, quantifier. All, for every, some, there exists at least one. So these words are telling about something about a quantity of a particular idea or particular things. So those words, those phrases are called quantifiers. Okay, so any doubt? No doubt, right? Please reply one at least.
Yes, sir.
Understand it?
Yes.
Okay, okay. So here, see here, some there are types of quantifier is there. So one is universal quantifier and some one more quantifier, that is existential quantifier. So, okay. So and whatever these statement, these example here, for example, how will this statement will be written in the form of symbolically? See, next points will be that only. So here. So statement 1, what is the statement 1? All squares are rectangle. So this statement can be written in the form of symbolic form, that is here. All x is belongs to S. Here S is denotes the set of all squares. Then x is belongs to S. Then P of x. P of x means that is open statement. Here P of x stands for open statement. X is a rectangle. See these statement, whatever these all squares are rectangle can be written in the form of for all x belongs to S. A second. For all x belongs to x, x is a rectangle. Here this is the whatever we statement. First statement, all squares are rectangle can be written in the form of symbolically. Okay, so this is symbolically we written, and this is here for all x belongs to S, comma x is a rectangle. Here S is the S denotes the set of all squares. So all squares are rectangle. That is a statement. Then here we denoted one set of all square as a S. Then x means that is rectangle here. So x, all the rectangles are belongs to square only. So S is a all square. Okay, so this is, and for all, whatever first in the first statement only all word is there. So that is we here we given that is for all. Next, whatever this for all will be written in the form of symbolically, that is this symbol, whatever this symbol. Okay, so this is the symbol for all. So this is like this. Okay, so this is the symbol for all. Okay, so this is whatever this for all we written the symbol this and x as it is, and this is a belongs to. Okay, so this is the belongs to. Okay, so this belongs to as it is. Yes is a, we denoted that is all squares. So yes, that can be written as it is. Next, comma x is the rectangle. So x is the rectangle, that is the one open statement, that is our statement. So that statement will be written in the form of P of x. Here P of x stands for open statement, that is x is a rectangle. So x is a rectangle can be written as a P of x. Okay, so here this symbol, whatever this symbol, that is the for all symbol. Okay, so whenever in the statement, any statement which contain all means all quantifier, that is here these all words all are for some, there exists at least one. So these all are the quantifiers. So any statement the quantifier all comes means you can write symbol like this. Okay, ulta a. So that is the symbol of all. Okay, so similarly in example 2, it is the example for every integer x, x square is a non-negative integer. So this is the second statement. We can rewrite it in the form of symbolic form. I will write, see here also we have the for every, here we written all. So here in the first statement we have the all and we written the symbol, that is this symbol, and next here also for every is there. So for every also we write the symbol, that is this symbol only. So see second example how we written. So for all x belongs to z, z is the integer. Okay, so z is the set of all integers. Z is the set of all integers. Next here, and q of x. Say q of x means that is it is open statement, that is x square is a non-negative integers. Okay, so this is we written in the form of q of x. So for every x belongs to z, comma q of x. Okay, so this is the, and here for every phrase also we use this symbol, that is all symbol. Okay, so for every whatever the whatever this every, so for every phrase also we use the symbol, that is this symbol. Okay, so this is for all, you can this symbol you can also use for all, for every, for each, for any. So whenever in the any statement if you contain for all, for every, for each, for any words, then you can use this symbol, that is this symbol. Okay, so this whatever these phrases are called universal quantifier. Okay, so why this is universal quantifier? See here all is there, here also for. Okay, and one more for each, for any. Okay, so those for each, and one more, that is for any. Okay, so these words for any, for each, all, for every, so these whatever these words we denote it as a these letters. Okay, so this is the symbol for these words, these phrases, that's why these are the universal quantifiers. Okay, so why universal quantifier? Because these words are telling whatever the, here all squares are, here this whatever this all the squares are rectangles, so it telling that all the, so whatever the whole things it's telling. Okay, so that's why we use this, we tell that is these things, that is universal quantifier. Okay, so whatever these words are telling about all, so that's why this is the universal quantifiers. Next here some words, that is some. So that is some part of determinants are equal to 0 and some part of determinants are not equal to 0. That's why here some determinants, so some part of particular determinants is telling about that this sum word. Okay, and here also there exists means that is some part of real number is whose square are equal to itself. So that is some parts is telling. So these are the existential quantifier and these are the universal quantifiers. So universal quantifiers are tells about all the idea of quantity. Okay, it will telling all the quantity, and here these words some there exist, so these words are telling about some part of quantity. Okay, so that's why these are the existential, these are the universal quantifier. So there are two types of quantifier: universal quantifier and existence quantifier. Universal quantifier, those telling about all the quantity. Okay, whatever the idea, whatever the things, okay, so that is telling about all the quantity. And here the some words are, that is some there exist, so these are telling about some quantity. Okay, so that's why these are the existence quantifier. Okay, so here some example of, so this is definition of universal quantifier: for all, for every, for each, for any. So these phrases written in the symbol, that is this symbol, and these all are phrases are called universal quantifiers. Okay, so next see example 3. What is the example 3? That is the sum determinants are to 0, sum. So this word is telling whatever this sum phrase is telling about some quantity is telling. Okay, some quantity of some part of quantity is telling. So that's why see here written as a, and this whatever third statement written in the form of symbolic, that is see here, the statement third can be rewritten as a, see here, there exist. So this is whatever sum, this sum word can be written in the this symbol. Okay, so x belongs to d. D means what? D denotes that is set of all determinants. Then see here, for some x is belongs to d. D is denotes set of all determinants and x is equal to 0. Okay, and then symbolically this is, so here x belongs to t, p of x means that is the open statement, that is the x is equal to 0. Okay, x is equal to 0, p of x stands for x is equal to 0. Whatever the statement we written in the form of symbolic. Here whenever the words for some for there exists, so that time you use symbol, that is this symbol. Okay, so this is we can call existential quantifier. Okay, and similarly example 4, see here example 4 there exists is there, so that's why see the symbolic form of fourth example. This symbol x belongs to r and q of x. Here there exist, here this whatever symbol that is we written, that is there exists, and r denotes the set of real number, q of x is open statement, and that is x is the real number whose square is equal to itself. So this is the open statement we written as a q of x. Next here, so whatever the symbols, this symbol, okay, so this symbol used to denote the phrases for some there exist for at least one. So whatever these words, these phrases are denoted in the form of this symbol, so that is we can call existential quantifier. Okay, so remember this existential quantifier symbol, this symbol, and words which are the words in the come under the existential quantifier, that is for some there exists for at least one. So these phrases are telling about, these phrases or these words are telling about some part of quantity. The quantity is telling about some part, not all. Okay, so that's why this is the existential quantifier. Okay, so and existential quantifier symbol is this symbol. Here this is universal quantifier, and these words are, these phrases are telling about all the quantity. Okay, so that's why this is universal quantifier and this is symbol for universal quantifier. Okay, so remember this concept, that is quantifier. 2 marks question. Uh, Most previous question paper they ask, that is what is the universal quantifier or what is the existential quantifier, and there may be some question paper they ask, that is what is the quantifiers. Okay, so only 2 marks question they will ask for this concept, particular for quantifier. Remember the quantifier means any words, some words are telling about, some words means these phrases. Okay, what are the phrases? Some phrases, that is all, every, some, there exist, at least one, for each, for every. So these words are telling about quantity of any idea, quantity of anything. So that is called quantifiers. And there are two types of quantifier, that is universal quantifier and existential quantifier. Though universal quantifier, those phrases are telling about all the quantity of particular idea, okay, particular things. Okay, so that is example all, for every, for each, for any. So these are come under universal quantifier, and symbols are, symbol is like this. This is the universal quantifier. Next, existential quantifier, that is for some there exists at least one. So these words, these at least, for at least one, for some there exists, so these phrases are telling about some part of quantity, it will not telling about all. Okay, so this is telling about some part of quantity is matching something. Okay, so that is the existential quantifier, and this symbol is this. Okay. So any doubt in the quantifier? Any doubt about quantifier?
No, sir.
Okay. Don't confuse about whatever I this sentence we converted into this symbolic form. This is not, this will not ask in exam. Only they will ask a theory. Okay. So what theory? That is definition of quantifier and existential universal quantifier. Remember this concept and remember these words. Okay. And here, so next concept, that is the predicate formula. Okay, so before we studied, that is the predicates. Okay, so what is the predicate? So in any statement, the predicates whatever there, that predicate will be denoted in the form of capital letters, and whatever the object or individual name can be written in the small letter. We have already seen the example, that is John is a bachelor. Okay, so here John is the individual name or object name, and is a bachelor is a predicate. Okay, So he is a bachelor, we can denote that is capital B, and in the parenthesis bracket we have to write individual name. So that is John. So John, whatever John is the individual name or object name. So object name can be written in the small letter. So we'll take small j and B of j. So that is a predicate. Okay, and that is we can say that predicate formula also. Predicate formula. So whatever say John is a bachelor, we written the in the symbolic form that is B of small j. Okay, so here j is a John, that is a individual name. Individual name. A second. A second. Okay, so j is a John. Okay, so and that is a individual name. And next b is a predicate, and we written in the form of that is capital letters. So b of j. This is four. This is one formula. This is a predicate formula. Okay, so before in the first we studied that is well formed formula for all these connective symbols. Okay, well formed formula we already seen here. So this concept you studied well formed formula in the connective symbols. For connective symbols, whenever particular variable standing alone is a alone is also called a well formed formula. Okay, so then if a is a well formed formula, negation of that also well formed formula. If a and b are two variable, two primary statement, that also well formed formula means the combination of these connectives. A conjunction b, a disjunction b, a conditional b, a biconditional b are also well formed formula. Okay, and any string of symbol containing statement variable, any primary statement plus connective symbols and parentheses are called well formed formula. These we studied these whatever this well formed formula. This concept is studied about in the connective for connective symbol. Whatever this well formed formula we seen for connective symbols. Okay, so formula that is standard formula. Okay, so that for connective symbols. Here whatever this formula, this predicate formula for predicates. Okay, so see here first what is the predicate formula. So this is the general form. Say p means here predicate, and next x1 x2 x3 up to xn, these are the individual names. Okay, so these are the individual name or object name. So whole this is the one predicate formula. Okay, in any predicate formula it can be single individual name or maybe two three of up to n, that is there in the predicate formula. Okay, see here b of j we written that is only single variable, single individual name is there. So this also one predicate formula. Suppose this is a combination of something that is here m of j. Okay, so this also one well formed. This also one predicate formula. This whole also predicate formula. And suppose if a b of John is a bachelor and one more John is bachelor and Sachin is a bachelor. So that time j comma yes. So this is also one predicate formula. Okay, but difference is in this predicate formula we have the individual name two, and this predicate there are the two predicate and single individual name is there. Okay, so these are all our predicate formula only. So this also here one predicate is there and remaining of x1 x2 up to x1, these are the individual names. So this also one predicate formula. Okay, so this is we see this is the two place predicate. Okay, and one place predicate, this is one whatever this is only single b of j, this is a one place predicate. Okay, whenever the number of individuals, based on that we have the that place of predicate we see in that one. So this is the n place predicate. Okay, because the individual names are up to n is there, so then that is n place predicate. And here x1 x2 up to x1 xn, these are the individual variable or object names. Okay, like John, Sachin, Rahul, so these are the individual names. Okay, so this is whatever this formula that is called predicate formula or atomic formula. Okay, remember this one. So whatever this formula, okay, so that is predicate formula or atomic formula. This single individual name also one predicate formula. Okay, suppose two, so that also predicate formula. Okay, So see here example here. See here, this is R only. This is a predicate symbol. Only R is given. There is no any individual name. So that time this is a zero place predicate. Okay. So this also one. That is this also one predicate formula. Next Q of X. Here this is here single object is the single individual name is this, so that's also a one predicate formula. This here there are two individual names, so this is also one predicate formula. This is also one predicate formula or atomic formula. Here P of a comma y, this is one predicate formula. Okay, so these all are predicate formula. Okay, so and this is general form of predicate formula. Okay, so next here what is the well-formed formula for predicate formula? Okay, what we studied well-formed formula for these four connective symbols. Okay, for connective formula, correct connective statement formula, this telling about well-formed formula, and this whatever this well-formed formula is telling about predicate formula. How the predicate formula will be there? What is the standard format? Okay, and what are the predicate formula valid? Those which are the predicate formulas are valid. Okay, so those rules will be there. Some rules will be there for predicate formula. So those rules telling about how the predicate formula will be there. Okay, so these are the rules. These are the well-formed formula for predicate formula. So see here what are the rules. First rule, that is an atomic formula is an well-formed formula. So this whatever this these are the atomic formula. So these all are these all are well-formed formula because these all are valid only in the predicate formula. Okay, so single, two individual, three individual names. So these all are the well-formed formula in the predicate formula. Okay. Say second rule. What second rule tells? If A is a well-formed formula, then negation of A is also well-formed formula. Say, suppose this is only zero place predicate. This is only predicate. Is there no individual name? So suppose if you convert this as a negation, so negation R. So that also well-formed formula. Okay. Suppose R is a well-formed formula, then negation of R is also well-formed formula. So this is the rule states about predicate formula. Okay, so this is the second rule. Third rule, if A and B are well-formed formula, there are two predicate formula, that is A and B. Then the combination of all connectives, A conjunction B, A disjunction B, A conditional B, and A biconditional B is also well-formed formula. Fine. If A is well-formed formula, and x is in any variable, okay, so then that time also here x of a or there belongs to, so x of a are also well formed formula. So this is the rules. Okay, so fourth rule. And this is fifth rule. What is telling about whatever if you constructing the predicate formula by using these 1 to 4 rules. So after constructing rules, whatever are the resultant rules, so that are resultant formula, that also well formed formula. Okay, so these rules will be there in the to construct a standard formula of a predicate formula. Okay, so remember whatever these rules, that is say similar of this connectives formula. Okay, so only thing is different. The format is different. The predicate formula is different, and here connective formula is different. Connective formulas come under like A conjunction B, conditional C, like that. So here the uh, predicate formula is like this. Okay, predicate symbol will be there. After that, individual names will be there. So like that. Okay, so this is the predicate formula. So any doubt in the predicate formula? So any doubt in predicate formula? If you have any doubt, ask me now. Mayu creation, ask the question or mute the audio. No doubt.
No, sir.
Okay, so remember these concepts: predicates. Next, yesterday we seen that is statement, function, and variable. After that, quantifier, and next predicate formula. Predicate, the statement, function, and variable. Next quantifier, next predicate formula. So important these whatever this concept, they will ask 2 marks question. Okay, so read the theory, read the example. Okay, you can understand it. Again, if you have any doubt, ask me. Can I ask these concept in the tomorrow test? Predicate, statement, function. Can I ask?
Yes, sir.
ಒಬ್ಬರೇ ಎಸ್ ಅನ್ನತ್ತೀರಿ ಎಲ್ಲರೂ ಎಸ್ ಅಂದ್ರೆ ಕೇಳ್ತೇನೆ ನೋಡ್ರಿ ನಾಳೆ ಮತ್ತೆ ಕೇಳಿ ಬ್ಯಾನಂದ್ರೆ ಹೇಳ್ರಿ ನಡೀತೈತೆ ಅಲ್ಲಿ ಲಾಸ್ಟ್ ಎಲ್ಲಿ ತಕೊಟ್ಟೇನೋ ರೂಲ್ ಆಫ್ ಇನ್ಫರೆನ್ಸ್ ಅಂದ್ರೆ ನಡೀತೈತಿ
ಬ್ಯಾಡ್ ಬಿಡ್ರಿ ಸರ್
ಓಕೆ ಓಕೆ ಬರ್ DMS notes ಬಟ್ರಿ ಇಟ್ಕೋರಿ so tomorrow test that is syllabus will be from starting point to up to rule of inference okay so study ಮಾಡ್ರಿ so 3 PM ಇರ್ತೈತಿ ನಾಳೆ ಚಲೋದಾಗ ಮಾಡ್ಕೋ okay ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಇರ್ತೈತಿ ಒಂದ್ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಟೈಮ್ ಕೊಟ್ಟಿರ್ತೇನೆ ಒಂದೊಂದು ಪ್ರಾಬ್ಲಮ್ ಹೆಂಗಿರ್ತಾವ್ರಿ ಡೈರೆಕ್ಟ್ ಕ್ವಶನ್ ಇರ್ತೈತಿ ನೀವು ಸಾಲ್ವ್ ಮಾಡಿ ಆಪ್ಷನ್ ದಾಗ ಚೂಸ್ ಮಾಡೋದು which are not suppose I will give one formula you have to check equivalence of that formula then you have to do in your rough book in a rough sheet after that whatever result then if you both are logical equivalence true then you can option is true like that I will give okay suppose I will give one statement formula is it tautology contradiction or contingency so on that time you have to do the in the rough sheet do the constructor to table and do that one whatever the things and then whatever last column if you have a contingency and then option you can click contingency like that some problems will be there okay so that's why study all the concept and practice the problem so if you have any doubt you can ask me still tomorrow 2 o'clock okay no doubt in this concept
No, sir.
okay I will end the session. So tomorrow, last concept, free and bound variable is there. So tomorrow I will discuss that one. After that, this unit will be finished. Okay, and next unit will be set theory is there. That also simple. Set theory and relation. So bye. So we'll see the next class. Thanks for joining the session. So best of luck for your exam. Thanks for joining the session.